If you've ever sent a project to print, you know that feeling, right? That little bit of anxiety where you're just holding your breath, hoping, really hoping, the colors come back looking the way you saw them on screen. Well, today, we're going to talk about that. We're going to see how we can move from that chaos of just hoping for the best to the control of knowing exactly what you're going to get.
And it's a totally fair question. I mean, why is it so hard? You spend all this time, all this effort, perfecting a design on your monitor. Then the printed version shows up and it just looks off. You know it's wrong, your client can see it's wrong, but trying to explain why it's wrong, that can feel like trying to catch smoke in a bottle.
And this right here is the heart of the problem. On one side, you've got this world of subjective feedback. Things like, it needs more pop, or it feels a little dull. That's not actionable, it's an opinion. But on the other side, we have objective data, hard numbers, things a printer can actually work with and fix. Our whole goal is to get everyone out of that subjective world and into the world of measurement.
So how do we get there? We do it with a system. You see, international standards aren't just a bunch of boring rules somebody made out. They are a shared global language, a system that's been specifically designed to bring order and predictability to what can be a really chaotic process. So let's look at the key building blocks of this system.
Okay, first up, and this is probably the most important thing you'll need to know, Delta E 2000, or as everyone calls it, Delta E. The absolute easiest way to think about it is as a ruler, but for color. It literally puts a number on the distance between the color you wanted and the color you got. All you have to remember is, the smaller the number, the closer the match. This is our foundation.
Next, let's talk about M1 and P1. So, if Delta E is our ruler, you can think of M1 and P1 as the official rules for measuring. It's like a recipe. M1 is the standard kind of light the measuring device has to use, and P1 is the standard light you have to use in the viewing booth. It's common sense, right? You have to use the same recipe and the same oven if you want to get the same cake every time. This makes sure that what the machine sees is what your eyes see.
And that brings us to the contract proof. Now, this is not just any old printout from the office inkjet. A true contract proof, one that meets strict international standards, becomes the legally binding blueprint for the entire job. It is the one single source of truth that everybody, the designer, the client, the printer, everybody agrees on. The final press run is judged against this one single document.
Okay, so now that we've got those key terms down, we can actually build our quality system. And it really rests on what we'll call the 3 pillars of quality assurance. Let's dig into the first one.
Pillar number 1. This is the foundation. It is all about having one and only one consistent way to look at and measure color. Every single critical decision, from approving that proof to checking the final sheets off the press, it all has to happen under the exact same M1 measurement and P1 viewing conditions. No excuses, no exceptions. This one rule eliminates the single biggest variable in the whole process.
So that brings us to pillar number 2, the contract proof we just talked about. This is so critical. Before that proof can become our legally binding blueprint, it has to pass a test. It has to be measured with a device to prove that it accurately hits all the target colors, all within the very strict tolerances of the ISO standard. And check this out. Look how specific this is. For a proof to even qualify as a contract proof, the average difference, that's the average delta E, between all the color patches on it and the official reference colors has to be 2.5 or less. This isn't someone's opinion. It's not a looks good to me. It is a pass or fail test based on pure data.
And all of that leads us right here to pillar number 3, the instrumented press check. This is the final stage where everything comes together on the printing press. And instead of just grabbing a sheet and holding it next to the proof and kind of squinting, the press operator uses a spectrophotometer. They are scientifically verifying that the sheet coming off the press matches the contract proof and the original data.
So what are they actually checking? Think of it like a checklist of vital signs for the print job. They're measuring the solid ink colors, how those colors look when printed on top of each other. They're checking the gray balance to make sure there's no weird color cast. They check for dot gain, also called TVI, and make sure the registration is perfect. And they do all this by measuring a little bar of colors, a control strip that's printed on the sheet. And of course, they're looking for any physical printing defects. It's a complete physical for the print job.
Okay,
So we have our 3 pillars. They're holding the whole system up. Now let's put it all together into a real practical workflow. Let's see what this actually looks like on a project, from start to finish.
And you know what? The workflow is actually beautifully simple. Step 1. You lock in your reference standard. This usually depends on where you are in the world. Faux-Grand Europe, Grockle in the US. Step 2. You create that binding contract proof based on that standard. And then step 3. You verify the final print run against both the proof and that original reference data, using your instruments. That's it. Simple, logical, and powerful.
Now, about those regional differences we just mentioned. They're pretty important. You don't need to memorize this whole chart, but you need to know which system your printer is using. Are you in a FOGRA world that calibrates to something called TVI, or are you in a Graycole world that's all about gray balance? Just knowing which language to speak is half the battle.
And you know, it's not just about color. We also have to talk about registration. That's how perfectly the different color plates line up with each other. And for modern printing, the target is an unbelievable 0.10 millimeters. That's about the thickness of a single human hair. Why does this matter so much? Well, bad registration is what makes small text look fuzzy or makes QR codes impossible to scan. This is a critical spec.
Okay, we have covered a lot of ground. We've talked about the problem, the system, the workflow, so let's wrap this all up with a concrete blueprint, a plan you can use to apply all of these ideas to your very next project and get those predictable results you're after.
Here it is, your 5-point action plan. Number 1, mandate M1 and P1 conditions for everything. 2, lock in the right reference standard for your region. 3, set clear numerical delta E targets. 4, write your registration tolerance right into the spec. And 5, insist that the final check is done with instruments and control strips. I'm telling you, if you put these 5 things in your next print spec, you will fundamentally change the outcome.
And hey, here is a fantastic practical tip for all you designers that really shows why knowing this stuff matters. If you have small black text on a colored background, don't make the text out of all 4 colors. Just make it 100% black or K only. This completely eliminates the risk of 3 of those colors being slightly misaligned and making your text blurry. It's such a simple fix for a super common problem.
And that really brings us to the final question, the one that sums all of this up. By using a system of standards, of measurement and verification, you can transform color from being a subjective, frustrating opinion into a clear, predictable, and even legally binding contract. Thanks so much for joining me for this explainer.